This video covers topic 15.5 over transformations of linear functions. For the top part of our notes, we're asked to make a table and graph the linear parent function y equals x. The table is given for us, so we just need to plot these points. -3, -3, -2, -2, -1, -1, 0, 0, 1, 1, 2, 2, 3, 3. So this is the equation y equals x, which is our linear parent function. So just like with quadratics, our linear parent function is the one that all other parent functions are based off of. Everything changes based off of this. So for this, they're asking us to replace f of x with just x and write the new equation for g of x and explain what's happening. So for problem 1, we take f of x and we replace it with x, so that is just x plus 3. Again, we're talking linear today, not quadratic, so we will not need a squared today specifically. This effect, if we add 3, means that it will move up 3 because it's a plus 3 in the back, so basically a k value. For problem 2, we replace the f with just the x, so pretty much we just get rid of the f for our new function. Comparatively, because of the negative in front, this will be reflected over the x-axis. And then a plus 4 is inside the parentheses. Inside does our horizontal. It's always the opposite of what we see, so plus 4 is really going to move to the left 4. So you might be starting to notice how this is not much different at all from quadratics. So problem 3, we're doing the same thing. We're replacing f of x with x, so 2x minus 5. From our original y equals mx plus b form, we can see that m is with x, so m is 2. And b is what follows. Whoa, sorry. So b is a -5. Now, they're asking us to compare this to f of x. F of x is already on the graph. So I go down to -5 on the y-axis. We begin at a -5. And then my m value is 2, so I go up 2, right 1, 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 up 2, right 1. And we're asked at the bottom, how does g of x compare to f of x? It's steeper, it's less steep, its steepness is the same. Excuse me. So just to make sure I label, this is g of x. So we can see that they're not the same steepness because same steepness would be the same slope. If I were to walk on g of x, it would be a much harder path than if I were to walk up f of x. Because I would most likely fall, g of x is steeper. So steeper is like the word narrow from quadratics. So problem 4, we replace f of x with just x, so we basically just get rid of it. And then to find our m and our b, we distribute, so 1/2 times x, 1/2 times -2. So we're now looking at this formula. So I start at b is -1, and then I go up 1, right 2 for my slope of 1/2. Up 1, right 2, up 1, right 2. I just need to go a little bit. So this is g of x. Now when we had quadratics, -2 in parentheses meant that our x was going to move to the right 2, and look where it hits the x-axis. It goes to the right 2. Now this one is asking, how does it compare? G of x has a larger y, a smaller y, and the y-intercepts are the same. So this time we're looking at our b values. Here our b value is 0. For my g of x, it is a -1. So -1 means that it's going to go down 1 and would be smaller because -1 is smaller than 0. So we're asked to transform here. So f of x equals x, so we're still looking at linear. So to shift up 3, we are going to add 3 to the back. To reflect across the x-axis, I'm going to put a negative in front, and that's it. To compress or make it less steep by a factor of 1/2 and shift right 2, compress or stretch goes in front. Right goes in the parentheses, and remember we're still not putting a squared because we don't have, we're not looking at quadratics. +5 on the inside means we are going to go to the left 5 because it is a positive. To reflect across the x-axis and translate 6 units down, it's going to be -x in front to reflect, and then -6 after. A vertical stretch, which means steeper, puts a 3 in front, and then to translate right needs a -4.5 in parentheses with x. And then for problem 11, a 1/2 in front will compress, which is the same as less steep, by 1/2. +7 on the inside will move it to the left 7. And +4 in the back will move it up 4. For 12 through 16, they're telling us f of x could be linear or quadratic because, as we've kind of seen through these notes, they do exactly the same things. They ask us to match the given equation with the transformation described. There could be more than one answer. So if you're doing linear or quadratic, if you have quadratic, the only difference is that there's a little 2. So if it's linear, which this one is, this example is, a in front can make it stretch, compress, or reflect. And then h inside moves it left or right, and k on the outside moves it up or down. So that part has stayed the same. So to do a vertical stretch and steeper are the same thing. So to stretch it, we need a big number in front. 13 has a big number in front, and that's it. To compress, we need a small fraction in front. We have a small fraction on 12 and on 16. To reflect, we need a negative in front. We have that on 14. To shift left, we need a +h inside the parentheses. We have that on 13. To shift right, we need a -h, so that would be 15 and 12. To shift up, we need a positive afterwards, so either after the parentheses or after the f of x. So we have that on 15. And then to shift down, we need a minus at the very back. We have that on 16 and on 13. So a quick check here, I have 2 numbers, 2 things happening. I have 3 numbers, 3 things happening. 1 thing, 1 thing. 2 things, 2 things. 2 things, 2 things. So for every number that you see that is not an x or an x squared, that means there is a transformation happening.